Hey guys, my name is Matthew D'Antuono, and this is my project number 1. So my project is based on a paper called the Voting Analytic Hierarchy Process Method for Selecting Supplier. And the problem that was addressed in this paper was based on Malaysia's furniture industry. And what the problem was specifically was trying to figure out which supplier to pick from a list of 10 suppliers based on a selection of 8 criteria and 13 sub-criteria. The method used was the analytic hierarchy process, in other words AHP, and more specifically for this paper, the voting analytic hierarchy process, which is also known as VAHP. VAHP is a lot like AHP. The only difference is that instead of knowing how much more important one criteria is than another, voting is done by a number of candidates to establish the importance of the different criterion. From the votes, the weights are then calculated to figure out which criteria is more important than others. The same 6-step AHP method is used, which is selecting supplier criteria, structuring the hierarchy, prioritizing the order of criteria or subcriteria, calculating the weights of the criteria or subcriteria, measuring supplier performance, and identifying supplier priority. As you see underlined on the screen, the only two things that are done differently are step number 3 and number 4, prioritizing the order of the criteria and calculating the weights of the criteria. These are done using the voting process. For the implementation of the problem done in the paper, I used both Microsoft Access and Microsoft Excel. Using them together, I was able to create a database that housed all of the different votes for each of the criteria and subcriteria, and from there I was able to export that to Excel to do some further calculations. So what I'll show you guys now is my criteria voting table. This is my database table for the main criteria, which are quality, responsiveness, discipline, delivery, financial management, technical capability, and facility. You can see that my tabs are listed 1st through 8th, which is first place votes, second place votes, etc., and how many each one of these attributes scored of each one of those. Same thing goes for the sub-criteria table. We have all of our sub-criteria. We have the criteria ID in the far left column, which links it back to the criteria vote table. And then again we have first and second, because most of these are compared as 2s. One of them is compared against 3. And the number of votes they received for either first, second, or third place. From here, we can click the External Data tab and export it to Excel. And what this does is this will put this as well as it can into an Excel format. And when this is done, with a little bit less formatting than this, you will get these tables. It'll look something like this. So what we have here is the same table that we had in Microsoft Access, but what we did here was we used a very tough to understand linear programming model, which can be seen right here. And what I did was, as they did in the paper, I used this linear programming model and these votes, and I was able to solve it using the Excel solver. So what I did was, I have my variables, which are my x's, and I've labeled these all 1s so I could show you guys an example of what happens. I put in what I was solving for, which is my weight right here. I have what I'm solving for is using is my x's, and then I have my list of constraints that are laid out down here by this formula. When I go ahead and hit solve, my solver results say that an optimal solution is found. Click OK, and you can see over here that we have these weights, which are then calculated, the total of these, and then normalized to get our weight out of 100% for each one. The exact same process happens for the sub-criteria down here. So these are my results. Unfortunately, I was unable to end up with the exact same results that they ended up with in the paper. I did notice a few calculation errors based on organizational problems. by the paper that I was using. So I went ahead and I used their weights to finish calculating. So from here, you use the main criteria weight and also the subcriteria weight, and you multiply the subcriteria weight by the criteria that it corresponds to, giving you your overall weight for each one. So as you can see here, we would multiply factory audit by quality, which would then give us this. The final step in the voting is how good each supplier is in different aspects, which gives them a score. So you see here, this is our rating of one supplier. So supplier 1, they got a score for 7 in factory audit, 8 in customer rejection, 9 in urgent delivery, etc. And we take these final weights and we multiply by the score, and it gives us a subtotal right here, which is the final weight for that supplier for that piece of criteria. At the end, we total up all of these scores, or all of these subtotals, to get our main total, and that's our score for that particular supplier. So when you have your list of all suppliers, all the scores that corresponds to them, you multiply the different scores by the different weights, and then you total it all up in order to get your total scores. And that's, once you have the total score for all 10 suppliers, you then use that to figure out which supplier you're going to use. So as you can see here, my results did vary a little bit from the results found in the paper, as you can see circled. The reason for this is unknown, possibly calculation error, and maybe my linear programming model was a little bit different than theirs. Most likely be the cause. Overall, the paper was well written and it had a lot of information. One of the problems with it was that it had a lack of problem-solving examples, meaning that they showed what they wanted to do and what the answer was, but not what they did in between, making it hard to understand their work completely. Also, it was simply an implementation of another paper's work. That paper is called The Appropriate Total Ranking Method Using DEA for Multiple Categorized Purposes, and that was by Noguchi and others in 2002. For future research, I could go back and I could recap what I did, possibly try and figure out the error that I hit in my recreation of the problem presented. Also, I could continue to apply different real-world problems with this and see how either I could improve on it or simply just make mine work the correct way as they have in the paper done. And then also for future research, I could try and solve a problem that's complete with all information. The paper that I used did not have a list of suppliers. As I showed you guys just at the end, they had the one supplier that was used as an example to find the total weight. In the future, I could find supplier information, rank them all, and find out which one would actually be better. Thank you for listening.